Yes, class. Am I audible? Ahmed, Usman, Anushka, Nair, Imad, and Jiva. So Jiva and Usman, this is your first class, no? Anushka and Imad already had the class. Okay, Anushka, no, test will be today only because see, last week also the test was supposed to be happen on last Sunday and Saturday. Saturday it was. Then I shifted because you were having your test, so that's why I shifted the test this weekend. At least let us have the class because tomorrow we have to cover the syllabus. If we'll keep on postponing it, then otherwise the time for the class will be left out. Okay, just a very short test is there. 4 questions are there. You'll be able to complete it.
Yes, ma'am.
Okay. If you have any difficulties, I'll be there.
Yes, ma'am.
Okay, regarding you both, Ahmed, Usman, and Jiva. So, see, class, we had started with this lesson, alternating current. Only one topic we had completed, that is AC dynamo. So this is completely based on magnetic flux. Are you aware of magnetic flux? See, AC dynamo or generator, this is basically a device that converts your mechanical energy to electrical energy. The current that you have been dealing till chapter number 3, your current, electricity, and all those current, that is what? That is direct current. And the current that varies with time, that is known as alternating current. So direct current is directly measured by battery cell that you have for a circuit. While you talk about alternating current, so special device, AC generator or dynamo is there which measures the current. So that's what we have studied, and half this part we'll have it in our backup class because it's not a very small topic that can be discussed briefly in 5 minutes. We'll have a backup class for it so that we can complete these topics. So few calculations we had made where average current and average value of EMF came out to be 2 I naught by pi or 2 E naught by pi. 2 by pi can be written as 0.637. So this much it becomes the peak currents value. All right, and RMS we had, which was I naught divided by root 2. The complete derivation was there for it. So I naught divided by root 2 and E naught divided by root 2. So do one thing, class. Take 2 minutes. At least let us just do this numerical. So for new students, just wait for 5 minutes. Let us just have this numerical completed. Then we'll start from a fresh topic. From there, you will be able to understand. Till the time others just write down this question and take 2 minutes to try it, then I'll discuss. See, the equation that is given to you is E is equal to 140 sine 300 T. Now, peak value of the voltage, its RMS value, frequency of the supply. So, I've not received any answers. At least try the first part. First part is very easy, directly given from the formula. Reply me in the chat box right now. See this equation, compare it with the main equation. Main equation is what? E naught sine omega t. So E naught is the peak value. From here, peak value is this. So directly you have to compare it from the equation. So E naught becomes 140 volt. So peak value directly you can write 140 volt from here. Now, if you have peak value, we had seen a relation between peak value and RMS value from the last class. So RMS value, if this is the answer of first part, for second part, see ERMS will be what? ERMS will simply be E naught divided by root 2. So E naught is 140 divided by root 2, this much volts. This will be the answer for it. You can put in even 140, you can put 1.41 for the answer also. So that will give you around 100 volts. Around, approximately this will be around 100 volts. Last part, what it's asking, frequency of the supply. See, omega t is given. From here, at least you can figure out 300 is omega. If omega is 300, then linear frequency you have to find out. So one relation we had seen between linear frequency and angular frequency. Angular frequency is 2 pi times the linear frequency, that is 2 pi nu. From here we have to find out value of nu. So how can nu be written? Nu can be written as omega by 2 pi. So see, omega is already given to you in the question. From here, if you compare both these equations, you get omega's value as 300. So this is 300 divided by 2 pi. You can write it as 150 by pi, this much hertz. Like this, you have to use these equations and solve. Now we'll move on to phase and phasor diagrams. That's an important topic from this. One more thing I wanted to ask you, Ahmed Usman. What's the current physics lesson going in your school?
Yes, ma'am. It's alternating current in this lesson.
Okay, this lesson is only going. Fine, fine. And what about you? Another student who's there, Jiva. What about you?
The same chapter, ma'am.
Same.
Chapter.
Okay. You both are in the same school?
Yes, ma'am.
Yeah, ma'am. Both in the same class.
Okay, okay. So just note it down, class, then we'll start from a fresh topic. That is purely resistive circuit, purely inductive circuits, and purely capacitive circuit. That's the basis for this lesson. As I've already mentioned in the last weekend, that these two classes coming, the Saturday's class and tomorrow Sunday's class, is very important for alternating current to build up.
Ma'am,
Yes, Anushka, say.
ma'am, is it only today's class that is for 2 hours, or tomorrow's class will be for 2 hours as well?
Tomorrow also, tomorrow, because it's complete AC, and most probably now your timings will be from 2 hours, for 2 hours only.
Yes,
So tomorrow's will also be 2 hours. Okay.
yes, ma'am.
Okay, now let's start with phase and phasor. So this is a different topic. See, phasor and phasor diagrams are what? We'll see the definition. First of all, let's see. See, the vector rotating vectors are known as phasors. For example, you have voltage, you have current that are present in your alternating current as the determinants. So these voltages and current, how are they related to each other? What's the phase angle between them? Which quantity is leading the other quantity? Is the current leading voltage or the voltage is leading the current? That is depicted by the phasor diagrams. And these currents and voltage, these are known as phasors. So in order just to have a rough view whether, see, we'll be having different circuits. For AC circuit, we'll be having one circuit that will be containing only resistor. One of the circuits will be having only capacitor. Other circuit will only be having inductor. Some circuits will have a combination. So you will have to analyze which quantity is leading other quantity. Other formulas will be there for each of the cases. So phasors are these rotating vectors only. They rotate in the circle. They are rotating in the form of circle. And then you have these phasor diagrams. For example, I'll show you. See class. See class, for example, if I say this is the position of, let's say, voltage, EM. This is the position of EM. Now this is at certain angle from the baseline. So this is your x-axis, this is your y-axis. And let's say one more. For example, this is the position of current. So you can observe certain things from here. Even if I just give you this part, if I just draw this part, then you can at least figure out the phase angle, phase difference between the current and voltage just by looking at this diagram, right? And these current and voltages together, these are known as phasors because these phasors are simply rotating vectors. So these keep on rotating and they actually do not rotate. It's just a hypothetical diagram that has been created by us to analyze it for different circuits. And this also gives an idea whether which quantity leads. Suppose I draw current here and EMF. This phasor diagram shows what? That current leads the voltage. If I draw EMF here and current back there, then it shows that EMF must be leading it. So this way for different conditions, we have a diagram. That is what is meant by phasors and phasor diagrams. So see, phasors are what? A rotating vector that represents a sinusoidally varying quantity. Exactly like this. See, in reality, current is a scalar quantity. It's not a vector quantity. Scalar is the only current is the only scalar quantity that has a magnitude as well as a direction that we had discussed in case of in the lesson current electricity. But here we are terming and naming it as rotating vectors because this is not an actual vector. Vector here represents just the rotation, just a quantity, physical quantity that is rotating. And then we have phasor diagram. So phasor diagram is what? It's a diagram that represents alternating current and voltage of same frequency as rotating vectors, means phasors, along with the proper phase angle between them. Now the usage of phasor diagram will be essential when we'll start with the circuit. So do one thing, note these 2 points, note down this phasor diagram, then we'll start from the first circuit, that is purely resistive circuit. Then we'll see how phasors diagrams get application and what are the phase difference between the physical quantities present in them.
Ma'am, what is it that represents? What?
Yes, Amat, what are you asking?
Ma'am, I just wanted to know what is this? A phasor that represents what is this word I want?
Rotating vector. A rotating vector that represents a sinusoidally varying quantity. Now, why sinusoidally? That we have discussed. In case of EMF's equation, we had seen E is equal to E naught sine omega t plus phi. Similarly, we'll be having sinusoidal equations for current also. That when we'll start with one of the circuits, then it will become clear. So this is just a rotating vector. Clear?
Okay.
Okay, I hope you must have written by now. Let's start with circuits which have only resistors. See, if you have circuit, an AC circuit which has only resistor, we call it as purely resistive circuit. Purely, see, this is totally different from your DC circuits that you have. In DC circuits, you have resistor, then you have an attached battery, key is present to close the circuit, then the current runs within that, and current is constant. If 5 ampere of current flows within this section of wire, then 5 ampere of current will only remain. But alternating current circuits are totally different. They have firstly AC dynamo over there to, as the angles will keep on rotating, as the angles will keep on rotating, the values of magnetic flux will keep on changing, and every principle that we had studied for, and the laws of EMI also that were applied for the AC dynamo. Now see, but here in alternating current, what happens? AC dynamo is there, and at every point, according to the time, the current changes. That's why we call it as alternating current. So only a resistor is attached with this AC dynamo, and here the AC dynamo's EMF is E naught sine omega t, and such circuits are known as purely resistive circuit. So if E is equal to E naught sine omega t, this is E is equal to E naught sine omega t. From here, if you have to write down the value of current, so see, E is equal to E naught sine omega t. Now we all know Ohm's law. What was Ohm's law? Ohm's law was simply V is equal to IR. So here instead of V, you have EMF. So EMF will become what? EMF will become equal to current into resistance, right? And what's the value of this EMF? This is E naught sine omega t. This is equal to IR. Right, class? Now see, if I write the value of current, current becomes what? Current becomes equal to E naught sine omega t divided by R. Class, one thing, E naught divided by R. This is I naught. That is the peak value of current. So this is I naught sine omega t. Now a major important thing. E is equal to E naught sine omega t. I is equal to I naught sine omega t. Can you see any phase difference between them? See, there is neither addition of any angle. Both of them have omega t at the end. What's the difference between these two equations? Only that here this is for voltage and this is for current, and no other difference is present. So simply you can say that both are in the same phase. That's why there is no phase angle present. So this is one of the major important things for AC to remember. See, class, otherwise AC will become difficult if you do not understand today's class properly. You have to understand certain points, like which quantity leads which quantity, which are in the same phase for which type of circuits. If you understand these three circuits properly, only resistive, only inductive, and only capacitive circuits, then the combinations will be dealt very fast. LCR is just combination of all three. You have LR combination, RC combination. That will be dealt faster if you have understood this. So please pay attention to all this and revise it once. Now see, if I is equal to I naught sine omega t, you have I is equal to I naught sine omega t. This is the equation of currents. So this shows what? Current and EMF both are in the same phase. These are phasors and these are in the same phase. So if I want to draw how to depict it graphically, we'll come to phasors, but let me show you how to depict this graphically. If I want to depict this graphically. This is time, this is EMF or current, let's say. See, for example, this is the value of current. This is the variation of current. This must be the maximum value of current, which we call as the peak value, right? This is known as the peak value. And if I wish to draw the value of EMF now, on the same graph, I'll start it from the same starting point. See, this is the same starting point from which I have started it. Can you see the same starting point from the same origin? See, maximum value I naught, E naught is different. This is for EMF. And this is for current. C class, what is this gap that we are getting? This is the difference in amplitude. This simply shows that EMF's value is higher. EMF's amplitude is higher than current. But we are talking about the phases. See, both are in the same phase. If it has also started from a region, current has also started from a region. So how will you depict this in phasor diagrams? Phasor diagram we have just studied. See class, even if you draw and learn these graphs and phasor diagrams properly, no, then when you revise it, you just need to see a look of this. Once you have this in your notes, then you can easily remember the theory portion of it. How? For example, even if I just see this figure, I'll be able to analyze both are in the same phase. If this graph is tougher, have a look at the phasor. See, this is EMF, value of EMF. So current will be where? See, since there's no phase difference, current will also be overlapping. This will be current. And there is no phase difference between them. This can be easily understood by this phasor diagram. That's the use of phasor diagrams. By this phasor diagram. And whatever will be there, omega t, that will be with respect to the x-axis that is present. But there will be no confusion. There will be no, you can just easily look at this diagram and see if E and I are in the same phase, then their equation will be I naught sine omega t and E naught sine omega t respectively. And if they are not in the same phase, then easily you can remember this by looking at the phasor diagram. First, tell me, any doubts still here? AC circuits having resistors only, this part, because this is the easiest one. Yes, Anushka, want to ask something?
No, ma'am, no doubt.
Clear? Oh, good. Anushka, which exam you have tomorrow?
Ma'am, I was not talking about exams, but like we were having
Okay.
class tests. That's what I was saying.
Okay. You are having class tests. So you people have your schools on Sunday, no? As well. Sunday also you have your school, no?
No, ma'am. Where I am, I don't have classes on Saturday, Sunday. Only Monday to Friday.
Oh, you're in India, Anushka?
No, ma'am. I'm actually not in India. I'm in UAE, Dubai.
Okay. Okay, class, if no doubts are there, do one thing. Start noting down this from here. Wherever you get stuck, ask me. This is the, honestly telling you, this is the easiest part. So if you've understood this now, then it's good. Because now what will happen? We'll just be building up things for inductor and capacitor. Wherever you get stuck, you can unmute yourself and ask me, or either send me in the chat box.
Ma'am,
Yes, Ahmad.
ma'am, can you just explain this phasor diagram again, ma'am?
Yes. See, phasor diagram is nothing. Phasor diagram is just a representation. We can depict two things graphically. The way in the first figure I have depicted the variation of current and EMF graphically. Similarly, it just shows how much difference is present between the current and voltage. So in case of purely resistive circuits, which we are dealing with right now, remember this point that both are in the same phase. This is a very important point that I have written over here. This is the main key part of this. So if both are in the same phase, how will you show that they are in the same phase? It means there is no angle between them. Phase angle between them is 0. So if phase angle between them is 0 degree, that shows what? Both are overlapping. If someone, either of it was exceeding, then I would have drawn it further or behind it, right? Since they are overlapping, that's fine. All right.
Yes, sir.
Okay, note it down. Then we'll start with the next type of circuits. Circuits having only inductance. Okay, class. Next type of circuit. Let's start. If somebody is writing, then just stop me. So AC circuits containing only inductor. So instead of the resistor, we'll be having inductor, and such types of circuits are known as purely inductive circuit. Why am I writing this all different times? Because this term will be used, purely resistive, purely inductive. Now see, E is equal to E naught sine omega t. We had seen induction already. Self-inductance is there, mutual inductance is there. Fine. So E is equal to minus L d I over dt we had seen. Now see class, if E is equal to minus L di over dt, just put in the value of E naught. So if you put in the value of E naught, this becomes E naught sine omega t equal to, don't write negative, you can avoid this sign because negative sign is there already. So negative sign will be helpful in case if you deal with Lenz's law. So right now we are not concerned with the direction. So simply write LDI over dt. By this also you will get an appropriate answer. All right. Now write down the value of current di from here. So what will you get? Di will be equal to E naught sine omega t dt divided by L. To get the entire current, we'll integrate it, right? We have seen these types of questions a lot in their derivations. So entire current will be what? When you will differentiate it, E naught by L is there. Just differentiate sine omega t. And how do we differentiate sine omega t? We get minus cos omega t divided by omega. Right, we have minus cos omega t divided by omega. This is what we are left with. So bring this omega closer to this E. So this way you will have I is equal to minus E naught by omega L cos omega t. Now see class, cos theta if you have anywhere, cos theta is equal to sine 90 minus theta. Cos theta is equal to sine 90 minus theta, right? So this cos also you can substitute it as sine 90 minus omega. This can be written as minus E naught by omega L sine 90 is pi by 2 minus theta you can write as omega t. Fine. Now see, minus sine theta can be written as sine of minus theta. One more trigonometric identity that can be applied. Sine minus sine theta if you have it can be written as sine minus of theta. Both are same. So finally your equation will become E naught by omega L will be there. And you can write this negative sine 90 minus theta. This becomes sine omega t minus pi by 2. Why? Because we have shifted this. This identity is used. So students who do not have mathematics, just learn this down for this derivation only. This will be used in your numericals a little less often. So for the derivation part, you can remember these two. Now class, one more thing you have importantly, this is omega L. What is omega L? Omega L, you cannot leave omega L in terms of this. You have a quantity which is known as omega L. So see, focus on this omega L now. I is equal to I naught sine omega t minus pi by 2. I am writing firstly, I have written E naught by omega L as I naught. Okay class, I have written this I naught is equal to E naught by omega L right now. We'll focus on this. What is this omega L? This is some quantity. But first see class this. This is I is equal to I naught sine omega t minus pi by 2. Whereas E was E naught sine omega t. Can anyone tell me by looking at these equations which quantity is leading the other quantity? Or what is the phase difference between them? What is the phase angle? Yes class, answer quickly in the chat box. What is the phase difference between them, or which quantity is ahead? You think this is quantity is leading, because definitely this you can see. In case of resistor, I was equal to I naught sine omega t, both were same. But here some additional component is getting added. Yes, Ahmed, perfect. That is pi by 2. See, this was in case of resistors. Now, in case of inductors, you can see this is minus pi by 2 is also there. It means this is lagging by pi by 2. If it was leading, it would have been plus pi by 2. It means now, what is the conclusion? Here you can easily conclude the fact that here current lags by pi by 2. Or you can simply say EMF leads current by pi by 2. This is the phase angle between. So first thing, it's clear this which quantity is leading the other quantity. In resistor, both were same. Inductor, both are different. Current is lagging behind. EMF is leading. Now coming back to this quantity which I was mentioning, omega L. Yes, class. Omega L, we write a simplified term for omega L, which is known as XL, known as inductive reactance. So I naught becomes E naught by XL. Now, what is XL? If you look at this equation, I is equal to E by XL, I is equal to V by R. If you see resistance, what the work a resistor does in case of a circuit having only resistor, that is now done by the inductive reactance. Simply in simple words, you can say if a resistor circuit is there, an EC circuit that contains only a resistor, then you can conclude the fact that the work of opposition that a resistor does is done by the resistor. If only inductor is present in the circuit and no resistor is there, only inductor is present in the circuit and no resistor is present in your circuit, then that work of resistance which you denoted by capital R, that is simply denoted by XL over here, which is omega L. So XL is equal to omega L, and it's just the resistance that is opposed or that is there in the obstruction or the path of the flow of current. Alternating current will flow. It will get obstructed. Why? Because resistance will be there, and that constant term is known as inductive reactance. It's just a term for resistance. See, I've written also. It's the measure of resistance or opposition offered by the inductor to the flow of AC circuit. It means XLC, it is equal to omega L. And omega L can be written as 2 pi nu L. Right now only we have seen 2 pi nu is written for omega. So for linear frequency, you can see XL and frequency both are directly proportional to each other. If both are directly proportional to each other, the graph between both of these will look like this. XL versus linear frequency graph. Now coming to the main part that we were discussing, phase and phasors. See, if I want to, now you will get an idea why we had the need for the phasors and phase diagram, and it will become a little clearer. Let's see it first graphically. If this is current, or let's draw EMF first. Okay, if this is current, let's say current is here. This is current. So EMF or voltage is ahead of current by 90 degree. It means it will start not from 0. Now it will start like this. This is 90 degree, making an angle of 90 degree. So now it will start from 90 degree and so on. The circuit will. This is EMF now. When the current begins its motion from origin, EMF has already covered this 90 degree path. That is depicted here. When I'll draw it, I'll redraw it. Wait, class. See, now when EMF is exactly 0, then current has become 90 degree. When again EMF becomes 90 degree, current is 0. Then again EMF becomes 0, current is at 90. It means EMF is constantly leading the current by 90 degree. Or even if you want to depict it by phasors, phasor diagram. Through phasor diagram, it will be much easier, because things are more clear on this. Things are clearer, then by looking at the figure, you can easily conclude so many things. See, for example, let's say EMF is there. This is EMF or voltage, you can say. So current will be lagging behind EMF. And by what angle? This angle will be 90 degree. In case of resistors, both were overlapping. Why were they overlapping? Because both were in the same phase. There wasn't any phase difference between them. Now current is lagging EMF by 90 degree. Clear or not, all of you?
Yes, ma'am.
Yeah. What about you, Jiva, Mariam, Rayan? Clear? Okay. Okay, class. So start writing from here. If still you have any queries, ask me in between. I'll repeat part. So what things are important? Let me just quickly briefly tell you this. See, this is a short derivation. Usually these derivations are not asked in your final board examination for purely resistive, inductive and capacitive circuits, but it's unpredictable. Anything can be asked in the exam though. From here, you have to remember these two equations for E naught and I naught. You have to remember XL and XL's relation between frequency. This has been asked a lot of time in your board exams. This graph between XL and nu. And then definitely your phasors. You just have to remember at any call this line that voltage is ahead of current, because these things become confusing at the end. Start noting from here. Any queries, let me know.
Amma?
Yes, Aman, say.
Yeah. Sorry, can you just explain that Excel again? What is it?
Yes, which is Excel.
Yeah.
Okay, see, Excel is inductive reactance. This name is inductive reactance. It means just the resistance. Resistance, resistance, that is the opposition that occurs in
Yeah.
the flow of current that is present. So that is for DC circuits. If inductor is there and AC dynamo is connected, means alternating current is flowing. Then for that circuit also there will be some opposition. So that opposition is measured by Excel. We call it as inductive reactance. Resistor, the way in case of a series circuit having only a resistor, resistance opposes the flow of current. Similarly, Excel does that same work in case of the circuit having only inductor in case of AC. So whatever physically meaning you have for resistance in normal DC circuits as well, same meaning you have it for inductance. It's just that since this is alternating current, it's a different, completely different branch. So here we have the different formulas for this also. So XL is related by self-inductance, which is given by XL is equal to omega L. Fine?
Okay.
Okay. Just text me done in the chat column once you have completed it here. Capacitor one we'll do tomorrow. Capacitor, and then we have combination, that is LCR. That is the major part that will complete us this lesson. So till the time once you have completed till here, keep on texting me done in the chat column. Okay, Jiva has done. What about others? Just let me know once you've done. Okay, Maad is also completed. Anushka Ahmed. All right then. See, regarding Ahmed and Jiva, since you both have not attended all the classes of EMI, is your electromagnetic induction prepared? So you can do one thing. See, we are going to have a test right now since this test was pre-decided only. You both can either attempt the paper if you wish by seeing the questions. If you think you are this much prepared to attempt the test and will be able to manage, you can give the test. Otherwise, you have the full liberty. You can just take the screenshot of the paper and you can complete it and solve later. Do take the video lectures recordings from me for the previous classes that have been missed by you. This is for Ahmed and Jiva since they are having their first class. I'll get you added on the WhatsApp group as well. Other students will be giving their test on EMI. This was decided in the last weekend only. So if you both let me know, if just have a look on the question paper. If you think it's fine for you, you can attempt the paper. It's not a very lengthy paper. If you wish, you can attempt the paper. Otherwise, you can take the screenshot and keep it with you. All right, other students, please start with your test and you know how to complete it. If you complete it, then you have to make it up into a PDF and upload it on the group. Regarding you both, Ahmed Usman and Jiva, if you think you'll not be able to attempt the test today, you can take the screenshot and you can leave the meeting and attend tomorrow's class and we'll discuss the backup. Otherwise, if you are comfortable, yes, Jiva, it's okay. You can have a screenshot, take the screenshot of this and you can leave the meeting because now only test will go on for half an hour duration and join the class same time tomorrow. But tomorrow we'll be having a class duration of 2 hours from now onwards because we are still on alternating current. That's why. Ahmed, you want to say something?
No.
Okay. Okay, okay. So it's okay, okay. Thank you so much.
Ma'am,
Yes, Anushka. Say,
I'm
completed.
done with the test. I'll be clicking the photos now and sending them.
Okay, okay, okay. You can leave, just submit the papers. Okay, thank you, Anushka.
Thank you, ma'am. Bye, ma'am.
Ma'am, did you receive the PDF?
Yes, Ahmad. Yes, I've received. You can also. Thank you so much, Ahmad.
Ma'am, just one more thing.
Yes, you say?
Ma'am, I think my brother has also joined your class.
Talha?
Yes, ma'am.
Okay, yes, yes, yes.
So when was the class? Yesterday, was there any class or is there today's class?
No, 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 that was cancelled. Didn't he get any information? Yesterday they were about to have the class on differentiation, 11th standard topic. Talha, Yusuf, and one or two students who were new. But yesterday's class couldn't be arranged, so I think information was sent. And today these kids have their maths class, so that's why the extra class couldn't be arranged. So on Monday only directly I'll talk to him. Monday, Wednesdays is batch timings.
Okay. I just want to
Okay.
confirm. Okay.
Thank you.